Hi, welcome to Mrs. Park's Algebra 1 class. We are finally moving on to Chapter 7, Lesson 1, Multiplying Monomials. Okay, so from here on, we're going to be dealing with monomials and polynomials. Okay, so why are we doing this? Many formulas contain monomials. For example, the formula for the horsepower of a car is H equals W times V over 234 to the third power. H represents the horsepower produced by the engine. W equals the weight of the car with passengers, and V is the velocity of the car at the end of a quarter of a mile. As the velocity increases, the horsepower increases. Okay, so here's an equation where you have monomials involved. Okay, so what is a monomial? Monomials is a number, a variable, or the product of a number and one of or more variables with non-negative integer exponents. It has only one term. In the formula to calculate the horsepower of a car, the term W V over 234 to the third power is a monomial, an expression that involves division by a variable like AB over C is not a monomial. A constant is a monomial that is a real number. The monomial 3x is an example of a linear expression. Since the exponent of x is 1, the monomial 2x squared is a non-linear expression since the exponent of a positive number other than 1. So identify monomials. Determine whether each expression is a monomial. Write yes or no. Explain your reasoning. So 10, yes, it is a monomial because it is a constant, so it is a monomial. F plus 2 plus 24, no, it's not because it has two terms. It's more than one term. It's not a monomial. Mono means like one, so only one term is allowed here. H squared, yes, this expression is a product of variables. That's one term. J, yes, it's a single variable, so it is a monomial. Your turn, numbers 1a to 1d. You're telling yes or no if it's there a monomial or not. Pause the video, finish numbers 1a through 1d, and come back when you're done. Okay, welcome back. So recall that an expression of the form x is called a power, or x to the nth power. xn is called a power and represents the result of multiplying n by itself n times. X is the base and n is the exponent. The word power is also used sometimes to refer to the exponent. So here's your base, here's your exponent. So 3 to the fourth power means 3 times 3 times 3 times 3, which is 81. Don't get it confused with 3 times 4. If they wanted 3 times 4, they would have written 3 times 4. I don't know how many times students make the same mistake over and over again. So again, 3 to the fourth power means 3 multiplied 4 times itself. All right. By applying the definition of a power, you can find a product of powers. Look for a pattern in the exponents. So if you have the same base here, and it's 2 to the second power times 2 to the fourth power, 2 to the second power means 2 times 2. 2 to the fourth power means 2 times 2 times 2 times 2. And when you're multiplying all of these together, you have 6 2's. So you can see a pattern here, 2 plus 4. You're adding the 2 plus 4, and you have 6. Here you have 4 times 4 times 4 times 4 times 4. And you have all together 5 of 4's. These examples demonstrate the property for the product of powers. So if you see a pattern there, we can make a rule of this. To multiply two powers that have the same base, add their exponents. So if you have a to the n power plus times a to the p power, you're going to just simply add those exponents, m plus p. So if you have m to the third times m to the fifth, this will become m to the eighth power. Same for this here, g to the 4 times g to the 6th, it's going to become g to the 10th. You're just adding the small numbers there. Add the exponents. Only and if only the base is the same. Alright. So let's try multiplying some of these powers. Okay, simplify in each expression. You have 6n to the third times 2n to the 7th. So you know the base is the same, n and n here. So what we do here, the numbers you can multiply. 6n times 2n, okay? So you're going to multiply the 6 and 2, okay, that becomes 12. Now 3 and 7, that's where you're going to add the small numbers, and that becomes 10. Okay, again, the big numbers you multiply, and the small numbers you add. All right, same concept here. 3, there's no other number in the big number here, so 3 stays the same. P, if there's no number, that means that's a 1 there. So p to the first times p to the third, 1 plus 3 becomes 4. T to the third, t to the fourth, 3 plus 4 becomes 7. Okay, so go ahead and try your turn numbers 2a and 2b. Okay, remember big numbers you multiply, small numbers you add. Okay, go ahead, try those two and come back when you're done. All right. So we can use the product of powers property to find the powers of a power. In the following example, look for a pattern in the exponents. Okay, so you're multiplying, you have 3 to the second, and you have that to the fourth power. So 3 to the second times 3 to the second times 3 to the second times 3 to the second. You do that 4 times, and you see a pattern here. You're going to add 2 plus 2 plus 2 plus 2, which is 8. So you have 2 here and a 4 there, it became 8. All right, let's try another one. R to the fourth to the third power. So R4, 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 add the 4s, and you have R to the 12th power. So you have 4 and a 3, that became a 12. All right, so these examples demonstrate the power property for the power of a power. All right, so the rule is, okay, to find the power of power, multiply the exponents for any real number a and any integer m and p. So you can now multiply those two small numbers if it's inside a power. So power of a power, you multiply. So b to the third power to the fifth power, you're going to multiply the two small numbers, make it b to the 15th power. G to the 6th to the 7th will be g to the 42nd. So multiply the small numbers. So power of a power of power. So what you're going to do is multiply these small numbers. 3 times 2 is 6. 6 times 4 is 24. So 2 to the 24th power, which is 16,777,216. And you can use a calculator for that. All right, so power of a power, you just multiply the small numbers. So simplify each expression. Power of a power of power, you're just going to multiply the small numbers as your exponents. Do those two problems and come back. All right, here's another pattern we see. Product of powers property and the power of a power property to find the power of a product. That's a lot of powers and properties. Okay, so in the following example, look for a pattern in the exponents. All right, so you have tw to the third power. That means t times t times t, w times w times w, because they're in parentheses. Now, if we didn't have these parentheses, that would be a different question. But because TW are both in parentheses, that third power applies to everything inside. So that means T to the third, W to the third. Again, everything inside parentheses, you're going to do to the third power. So T to the third power, okay, Y to the third power, Z second power to the third power. So Z squared to the third. Remember, you're going to multiply those two numbers and become z to the 6th power. Now, when you simplify this, the only thing you can simplify is 2 to the third, which becomes 8. So 8y to the third, z to the 6th. Okay. All right, so anything within the parentheses, you're going to give the power to everybody inside the parentheses. So a to the m and b to the m. So here's an example, negative 2 to the 5th power, negative 32. X to the 5th, you write x to the 5th. Y cube to the 5th power, you're going to multiply and make it y to the 15th power. All right, power of a product. Here's an example for geometry. Express the area of a circle as a monomial. Okay, so we know area of a circle is 2r squared, where your r is your radius. And here they're saying the radius is 2xy squared. So I'm going to replace, I'm going to substitute the r with 2xy squared. So now you have a power of power. So 2 to the second power is 4. So notice this pi doesn't change. It doesn't involve this pi because it's not in the parentheses. So 2 to the second power, x to the second power, y squared to the second power. So 2 to the second power is 4, x squared, and y to the fourth power, pi. So there's your area of the circle. Okay, so your turn, 4a and 4b. Express the area of a square with those lengths and the area of a triangle. So mind you, the area of a square is multiply each side, right side, so x squared. And area of a triangle is 1/2 base times height. Okay, so there are your two equations you're going to use for a and b. Okay, simplify expression. To simplify a monomial expression, write an equivalent expression in which each variable base appears exactly once, there are no power powers, and all fractions are in simplest form. So in order to simplify any of these, you have to make sure that it meets all these requirements. Okay, so whoa, look at this problem. It looks really complicated, but if you just take one step by step, it's really not that complicated. All right, so let's try this. First thing we're going to do is give the power to everybody inside. It's kind of like the distributive property. You're distributing the power to every thing inside, number or term. So 3 to the second power. You can look through this. I'm going to just do it over here in separate. So 3 to the second power is 9. X squared, so x to the second power. Y to the fourth to the second, remember 4 times 2, so y to the eighth. Okay, this number, now you're going to multiply that by whatever I have here. Okay, so I'm going to first do the small powers first. So -2 to the second power becomes 4 y to the second power. Okay, that's what came out of here. Now I'm going to do everything that's there to the third power. I'm going to put that here because I'm going to multiply with this red. 4 to the third power means 4 times 4 times 4, 64. Y second power to the third, remember multiply these two, and you get y to the sixth power. Okay. Now, I'm still going to multiply these two. So 9 times 64, and use a calculator, you get 576. Okay. And sometimes I like to just cross it out to know that I already done them. Next, x squared, there's no x term here, so x squared stays x squared. What's left is y to the eighth times y to the sixth. Now remember, when you're multiplying these powers, it's not power to power, you're multiplying, that means you add the small numbers. So y, 8 plus 6 is 14, so y to the 14th power, and that's my final answer here. Okay. All right. This actually looks more complicated to me, but if you want to review it, that's fine. They broke it down into little tiny bitty steps here. But again, all you're doing is getting power to power, and then if there's brackets and parentheses, that means multiply the two terms, and you get your final product. Okay. Here's your turn number 5. Simplify this term. Okay, so again, you're just doing product of a product, multiply that by whatever you have here, and then simplify your answer. Okay, and I believe that's the last question for today. So if you're done with your homework. Make sure you put it in your book bag so you can hand it in for homework credit tomorrow. And thanks for watching.